Math 1, let's take a look at our next lesson, which is a system of inequalities. Okay, and remember from last chapter, a system means two or more at the same time. Our equations are going to be in standard form. Okay? But today we have to graph two of them. And so you're going to have to use two different colors. You're going to see where the two colors intersect. The solution region is where you have two colors, both inequalities touching one section. So in this solution region right here, okay, all of these points, like this point right here, -3, 4 is a solution. Let's see if these are solutions. I like to find the point and plot it on the graph paper to see where it is. 0, 0 is right here. And that is, yes, in the solution region. Okay. This answer, this section is white. This is nobody. Okay. This section right here is only color 1. And this section is only color 2. But this is for both. Let's check 2, 0. Is this point in the solution region? No. How about 1, 4? 1, 4 is way up here. That is no. The solutions must be in the solution region. How about 0, 3? Are you a solution if you are on a solid line? And the answer is yes. 2, 1. This one's tricky. It's right where the lines cross, but one line is solid and one line is dashed. So the answer is no, because it's on the dashed line. Dashed does not count. 4, 1, that's definitely no. So in order to start graphing systems, okay, we just have to graph two of them, but we have to be organized. So I'm going to use two colors. My first color is going to do this entire inequality, okay, all the key features and the graph. I'm going to use purple. So we have a standard form. The key features are going to be the x-intercept and the y-intercept. To find x, I divide by 2. What is the x-intercept point? 2, 0. And right here, the y-intercept is going to be 4. Now, what type of line do you use if he has an equal sign? We use a solid line. And now we're going to test. If you put 0 in here and 0 in here, what does that entire side become? 0. Is 0 more than a 4? No, the answer is no. I'm going to go put all of this on the graph paper before I start finding the other one. 2 for the x-intercept, 4 for the y-intercept, and we set a solid line. Okay. Well, this is just a math problem. Okay, so long line with arrows, and we have a no right here. So should I color this way? The answer is no. Color the other way. Let's color this way. I'm going to switch to a different color so that I stay organized. For the second inequality, let's cover up y. What is the x-intercept? 2, 0. And the y-intercept, that's a negative. Be careful. -3. Should we use a solid or a dashed for this one? Dashed, Now it's time to test. 3 times 0 and 2 times 0 makes 0. Is 0 less than 6? And the answer is yes. Okay, so we have 2 comma 0 again as an x-intercept. His y-intercept is here. Okay, and we're going to draw a dashed line. So the dashed line goes here. Okay. And on the origin, okay, we can go ahead and erase this from before so we don't get confused. This time it was yes. So now I have to figure out which way to shade. Do I shade this way? And the green answer is yes. So we color everything on this side of the line. Okay. Are you done coloring? When you do inequalities, this is the white section. Nobody is here. This is only purple. This is only green. And so right here, this is the solution region. All of the points in here will work. Let's name a point in this solution set. Did everybody name the same point? Let's all pick the same one here. There's many, many points. Maybe you picked this one or this one or this one. I'm gonna pick 3 comma 5. You can use mine or you can use the point that you used, but we're gonna check it to make sure it's a solution. Okay? No, everybody picks different ones because there's infinitely many. Let's put this x number in x and the y number in y. 2 times 3 plus 5. Let's see if that is more than 4. What does this side make? Is 11 more than a 4? And the answer is yes, it worked. Do I have to check the second one? And the answer is yes, it has to work for both. So now I'm going to put the 3 in the x and the 5 into this y. Let's use parentheses. Okay. What does this calculation make? -1 is less than 6. Is that true? Yes, and it worked for both. I showed algebra to check. Let's do a story. Now we're going to do a system of inequalities. That means we have to write 2 of them. Okay. Players each get 2 servings. And guests get 1 serving. So the players is x. I'm going to put x by the players, and I'm going to put the y by the guests. Okay, so we have 2 for every x, and we have 1 serving for every guest. Okay, servings plus servings. Okay, and here is the total. You can order 20 servings at most. What's the symbol for at most? Okay, at most is the maximum, so you have to go less or equal. But there is one more total right here, and it says at least 12 people. What's the symbol for at least? Greater than or equal to. At least 12 people. At least 12 people. Are the people the players or the guests? And the answer is both. The x plus the y. And so we have a system of inequalities. We're going to have to graph using two colors. First, let's put our variables on this graph paper. X is number of players, and the Y is the number of guests. Okay. Let's stay nice and organized. So my first inequality, okay, I'm going to do the work here. Inequality number 1. This is standard form. So the x-intercept, 2x equals 20. What is the x-intercept? 10, 0. We have y equals 20. If you put the 1 and divide by 1, you still get 20. Does this first inequality use a solid or a dashed line? It's going to use a solid because of the equal sign. And now let's test. Okay, let's test 0, 0. Here I go. 2 times 0 plus 1 times 0 makes 0. Is that less than 20? Yes, 0 is less than 20. I'm going to go graph this right away. 10 is the x-intercept, and we have 20 for the y-intercept. And we have to graph a solid line. Okay? But remember, we don't want negative people, so we only stop at these points. Solid line. And 0, 0 said yes, so I'm going to put a little yes right here. And do I shade below the line? And the answer is yes. Okay, but we're not going to color any negative people. So we're only going to color, okay, in this little triangle right here. We're going to color everybody below the line, okay, but no negative people. I'll use my ruler here to help me not color any negatives. And this is the solution region for the first inequality. But now I have to do the second one. So let's take a look at this second inequality. To find the x-intercept, I cover up y. Okay, when you see something like this, x equals 12, it's already done. 12 is the x-intercept. Cover up x, okay, and again, we already have the y-intercept. Is this one going to use a solid or a dashed? Since it has equals, it's going to be solid. And now it's time for me to test 0, 0. So is 0 more than or equal to 12? And the answer is no. 0 is not more than 12. Let's go graph this with our second color. So we have 12 for the x-intercept, 12 for the y-intercept, and solid between the red dots. It's important you do all of the blue first so we don't get confused. This dot goes with this dot. These intercepts make the second graph. Okay, so I have that line. I'm going to color out or erase this word from before because this time the answer is no. So let's see, I'm going to put my ruler on the red line. Should I color this way? And the answer is no. I have to color the other way. So everything up here above the red line. This is a lot of graph paper. Okay. So when you do this, sometimes people like to darken up their solution region. Here's the white, That's nothing. This is only red, and this is only blue. And where did the two colors overlap? Okay, right here. This is the solution region. So sometimes people like to darken up that just so they can see it a little bit better. That is where they both intersect. And what are some possible combinations of people you can feed? You can feed how many players and how many guests? There are infinitely number of answers that you can put here, but we have to look in the solution region. You can pick any point in here that you want. Any of these combinations will work. Pick one from the solution region and put your answer in the blanks. Okay, the last thing we're going to do is practice testing. Let's test this point to see if it is a solution. 4 is x and y is 1. Okay, and so I'm going to split my paper in half, and I'm going to put each inequality on one side. So inequality 1, I'm going to put you here. Inequality 2, I'm going to put the work over here, just to stay organized. So let's put 4 into the x spot. 4, you're going to go there with parentheses, and 1, you're going to go into the y spot. What do you get when you calculate that? 10 is correct. Is 10 less than 12? Yes, it is. It's working for the first one. Now we have to try the second one. 4 goes into x. 6 times 4. Let's use parentheses. 8 times 1. What do you get when you calculate the left side? 16. Is that less than 8? And the answer is no. Okay, so 4, 1 is not a solution. It is not a solution. So maybe on the graph paper, 4, 1 is right here, okay, and that is not in the solution region. Maybe the solution region is way over here, okay? Is this a solution? He is not. But there are many solutions over there. It's just not him. Okay, we don't say no solution, because there's lots of solutions. Not him. Let's practice determining. Is this point a solution? Is 2, 3 a solution? No. Why is it not a solution? It's on the dashed line. Letter B. Is 5, 0 a solution? Yes. Yes. Why is it a solution? It's on the solid line. How about 4, 6? Is he a solution? Yes. Okay. Why? He's in the solution region. 0, 5. Is that a solution? No. Why not? It's not in the solution region. Great job drawing 2 inequalities today.